Here are solutions to perfect problem 4. Suppose that the average American, okay, we've seen this before. The average American IQ is 100 with standard deviation 15, and the average adult male is 70 inches tall with a standard deviation of 3 inches. A sample of Americans were chosen at random, and the normal probability plot shown here was created from their IQs. So what does this tell you? Well, because the data points are approximately linear, specifically they're not outside the blue bands. If that happens, then what that tells you is that the data is approximately normal. So our data is approximately normal, so we can do calculations using our z-tables. And what it goes on to tell you is that, yeah, that's true for IQ and for height. Okay. Number 2, sketch 2 distributions, shading, and calculating. So I think we've sketched these distributions before, but we haven't calculated any areas in them. Shading and calculating the area that corresponds with the probability that someone is shorter than me. So I'm 6'3", which is 75 inches. And we said that the mean height is 70 inches. And standard deviation is 3. So that gives us this little picture here. And so if I am 75 inches tall, that's, I don't know, somewhere over here. So I'd shade this area right here to represent the probability that somebody is, shorter than me. I would not shade that area. Shorter than me would be on this side. Good enough? Okay, and then do that again over here for Abraham Lincoln's IQ if the mean IQ is 100 and the standard deviation is 15. Fine. Mean 100, standard deviation 15. And we want the people whose IQ is lower than 128. So in that picture, that's somewhere in here. And lower than would be over here on the left-hand side. But we're supposed to calculate those areas. So you can calculate those areas in a couple of different ways. You could use a calculator, use your stat functions on a calculator, or you can calculate the z-scores and then look those up on a table. I think because, so this is part 2 here. In part 3 it asked me to calculate the z-score, so maybe I'll jump ahead and do part 3 now, and then I'll finish up part 2. My z is my height minus the average height over the standard deviation, which is about 1.67. And Abe z would be 128 minus 100, that mean, divided by that standard deviation. So we get 28 over 15 is approximately 1.87. So we have these two z-scores, and now that we know these z-scores, we can figure out the area. You could use a table or something. We want to know what's the probability that somebody is below 1.67 on our table. So go to some tables and you look up 1.67, what you'll find is 0.9525 is the area below 1.67 standard deviations above the mean, and 0.9693 is the area below 1.87 standard deviations above the mean. Let's see, maybe parenthetically here, I'll point out that you could also use Normalcdf. And then what you got to do is give it your lower bound and your upper bound. So some big negative number, whatever, and then all the way up to our IQ, or our height. But then you have to tell it what your mean is and what your standard deviation is. And that'll give me 0.9525. So maybe I should say tables or this. And same idea here to get those areas. And then part 4 just says, kind of tie this all together. Another way of thinking about this, really the work that you just did. Those are 2 horrible normal distributions. Let me try again. Meh. Not much better, but I guess they'll do. We can use standard normal distributions. So 0 is the mean and 1 is the standard deviation. We can do that in both of these cases. Mean 0, standard deviation's 1. And if we look for, let's see, let me change colors here. 1.87 as a z-score, that's somewhere in here. Short on room, I think I could squeeze it in. 1.87. And 1.67, same idea, that's somewhere over here. And what we figured out is this area to the left of 1.67 is 0.9525, and this area to the left of 1.87 is 0.9693. So really what I was going for in this problem is just showing you what you're doing in 2 is really the same as what you're doing in 4 if you convert to z-scores. And I guess that's the end.